Hello everyone. So for this lecture, I'm going to discuss an introduction on data. So what is data? At its simplest form, you can say that data is any collection of facts. It's kind of hard to give a boundary of what is and what is not data because almost anything can be data. This is why when we realized the power of analytics, we started to collect data from almost anything because almost anything can be data. Data, for example, can describe some value, it can describe some fact, some statistic, or it can even be any representation that can be interpreted in a meaningful way. I think the best way to illustrate what data is by showing examples. So, some examples of data. Again, data can be facts. So, a person's gender, that can be data. A person's name, that's data. If you're collecting the housing data, for example, whether or not the house is yellow, that's data as well. Measurements as well can be data. So the land area of a city, that's some kind of measurement. That's some kind of data as well. The width of a flower petal, that's data. Energy usage of a refrigerator, and then the budget of a flood control project. Unstructured representations can also be data, something big represented in some kind of way. So text from a book, that's data. Even photographs can be data as well. Photo of a mango fruit, documents from legal discovery. So when you're working as a lawyer, for example, and usually have a lot of documents, and the all of those are called discovery. So documents from legal discovery, that's considered data. Audio, sound can be data as well. Audio recordings of whale noises can be data as well. Statistics can be data as well. So average life expectancy in a country, an athlete's player impact estimate. I gave an example of this in the previous video. So this is an advanced metric in basketball, if I remember correctly. And then the median household of an income city, that's data as well. That's some kind of statistic. So let's look at what we call a data set. The data set, this refers to any collection of data as well. Data sets can be structured in a specific way. For example, tabular data is structured into a table. Something that you see on screen right now, that's a tabular data. Relational data, which is structured into relational databases. So if you've heard of SQL, that's relational. It's basically a collection of interconnected tables. You also have JSON data, if you've heard of that. That stands for JavaScript Object Notation. That's another way of structuring data. But for this course, we will usually structure data sets in tabular form, something like this. So let's look at the parts of this data set right here. So you have variables, or also known as features, columns. So these mean the same thing. Variables refer to the columns in your tabular data. These are known as features as well. So if you look at the example that you're looking at right now, there are 5 variables in this data set, excluding the first column right here. For sample number, you have age, type, final bill in PHP, and then the number of items, and this is another variable as well, is a store member. So you can imagine that this data set would probably be a representation of the transactions on a store, for example. You also have samples, or also known as observations or rows. These refer to the rows in your tabular data. Each row in tabular data represents one observation. So from this example right here, every row is one observation, every row is one sample. And depending on the context, a sample can mean different things. For this context, for example, the samples would refer to a specific transaction. Sample number 1 is a specific transaction, sample number 2 is another transaction, sample number 3 is another transaction, and so on. You also have values as well. Values refer to the specific value of a specific sample and variable. So if you look at the individual cells in this table, that would refer to the values. So looking at 2399 right here, this is the value associated to sample number 1, specifically from the variable final bill. If you look at something else, you have, let's say, young adult right here. This is the value from sample number 2, specifically from the variable age right here. For example, 2 right here, this number is also a value, of course, from sample number 4 from the variable number of items. You also have index. Not all data sets have an index, but most of them have. And this is a useful part of your tabular data. So index, this refers to the special column that represents a unique identifier for each observation. Each observation will have a unique index value. So in the example that you see right here, the index right here would refer to the sample column right here. So every different sample also has a different sample number. So it doesn't always have to be called sample, the specific column. It could be called index, it could be called number, etc. As long as this represents a unique identifier for each row, that would refer to the index of the index column of your data set. Okay, now let's look at the different types of data. So there are 2 types data can appear in. It can be quantitative data, qualitative data. So starting with quantitative data right here, it is also known as numerical data. So it comes from quantity. So if you want to remember, it describes some kind of quantity. This type of data refers to some quantity, of course, or some numerical value. And the way you would judge if specific data is quantitative, you basically have this rule of thumb right here. If it would make sense for you to perform arithmetic operations on that specific piece of data, like if it makes sense for you to add those values, if it would make sense for you to multiply those values, if it would make sense for you to find averages on those values, then that can be considered quantitative data. So specific examples of quantitative data would be age, income measurements, length, duration, etc. And quantitative data can appear either as discrete data or continuous data. So discrete data, so it's discrete, it's specific countable values. For example, if you have the number of children, that would correspond to discrete data. The way you would understand, or the way you would see if your data is discrete or not, is if your data can have in-between values. So for example, it wouldn't make sense for you to have 0.57 children. It wouldn't make sense for you to have 0.01 children. So your children can only be 0, 1, 2, 3, etc. That can only be the possible values for your number of children. So if your data appears like that, then your data would be discrete. The opposite of discrete data, on the other hand, you call them continuous data. So any value that comes from a continuous range, for example, that's continuous data. An example of that would be height, so a person's height, for example, or some object's height. So the height of something can be from 0 to infinity, any value in between that range. So values can be 1.5 centimeters, 400.3 centimeters, etc. Any value in between. It makes sense for you to have in between values. You can just divide the values in as small possible, and the smallest possible units, for example. That's continuous data. On the other hand, you also have qualitative data. So it comes from quality. It describes some form of quality. It's also known as categorical data. Again, it represents some form of quality or some form of category. It's also known as categorical data as well. If your data is not meant to be performed arithmetic on, then it is qualitative data. So it's basically the opposite of quantitative data. The rule of thumb again that you would use, if it doesn't make sense for you to add these values, then that's qualitative data. Example of these would be gender, color, city, etc. So that's qualitative data right there. And qualitative data can be ordinal or nominal. Qualitative data that can be arranged in some natural order is ordinal data. So the mnemonic for that would be ordinal, or order. An example of that would be some kind of opinion. So if you ever tried filling up some psychometric form, for example, where the responses would be either of these 5 values: strongly disagree, disagree, neutral, agree, disagree. So while these are still qualitative data, they describe some kind of quality, there's some natural ordering to the possible values of this data right here. So for example, it would make sense for you to add these values. So they're still qualitative, but at the same time, you can order them in terms of increasing agreement. So from least agreement, that would be strongly disagree. Then in increasing agreement, disagree, neutral, agree, and then strongly agree. Sorry, this one right here is typo. So this should be strongly agree. This term right here. Okay, so if you can't have a natural ordering for your qualitative data, then that is considered nominal. It doesn't have any inherent order. Something like book titles, cities, names, gender. It doesn't really make sense for you to order them. But to be honest though, you can almost find a way to order anything. So for example, any book title, any city name, you can arrange them alphabetically. While this is some kind of ordering, it's not really considered as natural ordering. So it's still not considered ordinal data, because if you are arranging book titles in alphabetical order, there's no meaning in it's just the way you would arrange it in a dictionary. Whereas if you're comparing that with something that has natural order, there's meaning in ordering strongly disagree before disagree. It's the order of agreement. It has inherent order. So if we go back to the example data set right here, we can sort of check one by one what types of data this is. So age right here, this is, of course, it doesn't make sense for you to add these possible values right here. It doesn't make sense for you to add old with young adult, etc. So this is, of course, qualitative data. It represents some form of category. And you can also check, is this ordinal or nominal? If you look at the possible values right here, is there some sort of natural ordering for these values? And if you think about it, yes, you can order these categories by order of age, by how old this is. So the oldest possible category would be old. The next oldest would be adult. The next oldest would be teen. The next oldest would be child. And the youngest would be infant, for example. So that's an example of qualitative data. Final bill, on the other hand, of course, this one is quantitative data. So this describes some kind of quantity, some kind of measurement, the amount that the transaction or the person paid for in this transaction. So it would make sense for you to find the average of these. It would make sense for you to add these values together. It would make sense for you to total these. So that's considered quantitative. And it's also continuous as well, because it would make sense for the final bill to be 2399.513. I mean, to be honest, it depends on the denomination of the money. It depends on the currency. It might not be possible for this specific store, for example, to give to have specific centavos. So that's why it could be discrete. So it still depends on the context as well. But just by looking at the type of value this is, final bill, money, it could be continuous, because money can be any value from 0 to infinity, for example. Number of items, on the other hand, this is obviously quantitative as well. And for the context of this data set, we don't have the full context, but we could imagine that this variable right here would represent discrete data, since it wouldn't make sense for you to have 1.5 items. It wouldn't make sense for you to buy 0.3 items, for example. It can only be 0, 1, 2, 3, 4 until infinity. So this one is discrete. Is a store member? This one is qualitative as well. It can only be yes or no, for example. And there's no natural ordering between either yes or no. So this could be considered as nominal data. This one right here, type, it might be a little bit misleading because these are numerical values, 1, 2, 3, 4, 5. But I will discuss later why it's possible that this is not quantitative data. There's some missing context right here, but let's move on in the slides right here. Okay, so in some cases, you might find yourself looking for a way to convert your qualitative data into quantitative data. And as discussed earlier, qualitative data doesn't really convey some type of measurement or value. And you might need to look for a way to represent or to perform arithmetic with these values. For cases like these, you will need to find a way to convert your existing qualitative data into quantitative data. So this example data set right here, this is just a small data set with 1 variable and 5 samples. So there's no context right here, but you can imagine that this would be responses to a specific opinion. And I've shown an example of this. An opinion can have 5 possible values from strongly agree until strongly disagree, for example. So this table right here, it shows respondent data, and let's say you want to find a way to convert opinion into qualitative data. Maybe it would be interesting to look at the overall opinion of all of the respondents. So you need to find a way to combine all of these opinions into a single measurement, for example. So one thing that you can do is to convert all of these into counts. Basically, you count the number of occurrences of every possible value. So you count how many occurrences of agree are there, how many occurrences of strongly agree are there, how many occurrences of neutral are there, and so on for every possible value. So when you do that, you will end up with this conversion right here. This is the summary of all of them into counts. So the opinion strongly agree has 2 responses, or 2 responses answer strongly agree. That's the more proper way of saying that. 2 responses responded with agree, 1 response responded with neutral, 0 responses responded with disagree, and 0 respondents answered with strongly disagree. So by converting your data into counts like this, you will end up with values 2, 2, 1, 0, 0, which are, of course, quantitative data. And this quantitative data right here will convey some kind of measurement, how many, and you can sort of get an insight on how many opinions would be strongly agree, which is the prevailing opinion. For example, the prevailing opinion right here would be either strongly agree or agree. So you have an insight now with your data. So a simple count like the one that you're looking at right now, it does provide us with measurement and values. It does convert your qualitative data into quantitative data, and it also gives you insights on your overall opinion. But you do lose details if you convert your opinions into counts like this, because you are now missing the individual values of every specific respondent. So you're missing a lot of details right here. All of the individual answers are now lost because you have summarized them into counts instead. So this works as a conversion, but there's a different way of converting your qualitative data without losing all of those details. So this is what is known as the encoding of ordinal data into qualitative values. So to preserve the details of your opinion data right here, you can instead take advantage of the ordinal nature of opinion because there is some specific ordering. What you can do is you can replace each response with a corresponding numerical value based on the order of how much a respondent agrees upon the opinion. You can convert, for example, strongly agree to the value 5, agree to the value 4, neutral to the value 3, disagree to 2, and strongly disagree to 1. So you do still preserve the underlying ordinal nature, and at the same time you also have measurements at this point. You also have quantitative data at this point. And the replacement values that you end up with also makes sense as well, because this, you can imagine this as the amount of agreement this specific answer has. So 5 is high agreement, that's why the value is also high. 1 is low agreement, that's why it corresponds to strongly disagree, so the value is also low, 1. And the middle value, like 3, is in between 5 and 1, for example. So the underlying issue or the underlying meaning of your values are also preserved as well. So from this data right here, you convert agree into 4, strongly agree again into 5, agree into 4, neutral into 3, and then strongly agree in this case into 5, ending up with this data set right here. Now your opinion variable is now quantitative. And how does this help? You can now perform arithmetic with these values right here. One interesting insight that you can find is, of course, the overall opinion of all of the respondents. So you can find the average value of all of these right here in this column, and you add all of them right here. That would be around 21 divided by 5. You end up with an average value of 4.2. So your opinion variable has an average of 4.2 for all of your respondents, and this gives you an insight on what the overall opinion is. And the value that you end up with here also has meaning as well. The value is close to 4, so meaning the overall opinion is close to agree. So if you end up with an average that is low, something like 1, it's close to 1, then your insight would be that the overall opinion is disagreement. And that's how you end up with an interesting insight like that. Okay, what about nominal data? What if your variable, what if your data doesn't have any inherent ordering? So this is also another small data set with one variable, and this variable right here represents the genre of a specific movie. So it can be, let's say, horror, comedy, action, drama, thriller, etc. So this is qualitative data, but at the same time it's nominal. There's no inherent ordering. You can't think of a way to order horror, comedy, action in some way. So if you replace this with numerical values, sorry, that's spoiler. If you replace this with numerical values, there's no sense to the numerical values that you end up with. So for example, if you replace horror with 1, comedy with 2, action with 3, and so on, you can do that, but it doesn't really make sense for you to do that because 0 and 1 doesn't have any inherent meaning. So if you assign 0 to horror and then 1 to comedy, horror and comedy isn't really close to each other. There's no ordering in between them. That makes sense. So meaning you cannot use the same encoding that you do right here. So what you would do instead is you would use what is known as dummy values. So this process right here for every possible value a genre could have, so horror, comedy, action, thriller, drama, for example, you're going to create an entirely new column for every possible value of genre. And you would give these names based on the possible values. So you end up with all of these values right here. So I apologize, the table right here is a little bit cut off, but you can just imagine that there's more to this that I just cut out. So you have here the horror genre column, the comedy genre column, action genre column, and then thriller genre column. One column for each possible value genre could have. And then what you're going to do for each of those columns, if the genre, for example, is horror, you're going to mark 1 on the horror genre and then 0 for everything else. If it's comedy, you're going to mark 1 for the column with the comedy genre and then 0 for everything else. And then you're going to do the same for every single row. And you're going to end up with a data set that looks like this. So you can now discard this genre column right here, this one. And now you have these, what are known as your dummy columns or your dummy variables with dummy values 1, 0, and etc. So while dummy columns are not as meaningful as encoded ordinal values like these, for example, the conversion from qualitative to quantitative will help during the modeling phase of analytics. So for now, we can't really appreciate what this conversion does for us, but this helps with the modeling phase of your analytics. Right now, it just seems like we're just adding extra columns when we can just summarize this into one. But this has a use. We just can't discuss it right now because it's a little bit outside of the scope for today. One more thing I forgot to mention when it comes to encoding ordinal data. The encoding that you choose right here, strongly agree to 5, agree to 4, etc. So this will be up to you. You can also reverse this. You can say strongly agree, you assign 1 to that. Agree, you assign 2 to that, and so on. As long as you preserve the natural ordering, then that works. You can also say that strongly agree is positive 2, agree is 1, neutral is 0, disagree is negative 1, strongly disagree is negative 2. So that is also a possible way of encoding it. As long as you preserve the ordering, that's a valid encoding. Also, one more thing when it comes to dummy values, if you have a variable that can only have 2 possible values, so membership, for example, can only be either member or non-member. Instead of creating 2 columns for each possible value, you can just use 1 for that one. So you can write 1 for member, 0 for non-member, because adding an extra column will be redundant since anything that has a 0 value means that it is not a member. Anything that is 1 means that it's a non-member. You can just summarize the dummy values into one variable. But again, this only works for categorical or qualitative variables that have 2 possible values. Okay. In some special cases, though, you can have some interesting ways of converting your qualitative data into quantitative data. And this really depends on the context. This depends on the specific value. So, for example, date. This is normally qualitative data, but you can convert this into quantitative data by separating them into month, date, and year. So, and then you use the numerical values for month, date, and years. For example, the date September 29, 2025 can be converted into 3 columns, 9 for the month, 29 for the date, and then 2025 for the year. It can also be converted into something like days from, where you can replace the date with the number of days from a specific date. So for example, September 29, 2025 can replace that with the number of days from January 1, 2025 until September 29, 2025. So you're just going to end up with a single value. And either of those are possible conversions. It depends on the context, which one is the better conversion that would work for you. But when you do that, so date values that are close to each other will have a similar date as well. So any of these conversions right here, you will end up with a natural ordering as well, with a natural encoding where you preserve similar dates will have similar encodings as well. Now that I mentioned that, that reminds me, I forgot to mention one of the reasons why you wouldn't encode something like this into ordinal values, into 1, 2, 3, 4, 5, for example, because if you, I think I mentioned this, but I think I wasn't clear. So if you encode horror into 1, encode comedy as 2, for example, it doesn't really make sense that 1 and 2 are close, because horror and comedy are not close to each other. So that's what I meant a while ago when I said the natural ordering is non-existent for this specific value type. So moving back here, sorry for that short tangent. So other types of values that can be converted into quantitative values, location, for example. So location would be, let's say, city. So Quezon City, like Makati, for example. Instead of using qualitative variables like that, you can instead replace them with geolocations that represent longitude and latitude. So you will end up with two values, two numerical values. And with these, you end up with values where locations that are close to each other will have similar longitude and latitude. So the longitude and latitude of, let's say, Manila and Quezon City would be similar to each other, and because they're also locations that are close to each other. But if you compare that to the longitude and latitude of a faraway location like Cebu City, it won't have similar longitude and latitude values with Manila, for example. So this conversion even allows you to easily calculate distances between location values as well, if you have the longitude and latitude figured out. Color, for example, this is qualitative data as well, but you can convert this into quantitative data by converting it into RGB. So those of you who have some background in multimedia, for example, so any color has a corresponding RGB value. It doesn't have to be RGB, it can also be HSL values or CMYK values, but all of those are qualitative conversions. And when you convert your color, let's say red and maroon, for example, these are similar colors, and the converted RGB values for those colors will also have similar values as well. So you preserve the ordinal nature of color. In some cases as well, you also might need to convert quantitative data into qualitative data. So this is the reverse this time. So you have here a data set of different houses and the area, the floor area of that house. So of course, if you look at this, this is continuous quantitative data. In some cases, you might want to convert this into categorical or qualitative data as well. So there are many reasons why you would want to do that. You might be interested in counting how many samples there are that have a high value for specific features. So for example, you want to know how many values are large, how many values are small, how many house areas are large, how many house areas are small for this specific example. So simply counting frequencies for every value will not lead to helpful insights, because you will end up with too many possible values that just end up with low frequencies. So if you count how many values have this exact value, how many values have this exact value, how many values have this exact value, you're not going to end up with something meaningful. You're not going to end up with a meaningful insight. You're just going to end up with 1 and 0 values because these values are very unique to each other. So instead of doing that, you would want to convert these variables, these values, into qualitative data. So what you're going to do, you're going to create bins. So these are known as bins, and bins are basically a range of values, a range that your values can fall in. For example, we create 3 bins out of this data right here. And let's say the first bin is 0 to 399. So as you notice right here, this represents a range. The second bin is the range 400 to 799.99. And then the last bin is 800 to infinity. And you can also assign descriptive names to these bins. So this range corresponds to small values. This range corresponds to medium values. And then this range corresponds to large values. After creating these bins right here, you're going to go back to your data set and you're going to, one by one for each row, replace a specific value with a specific bin name. So 423.5, this value, for example, you check which range or which bin does this value belong to. So it does not belong in this bin, it doesn't belong in this bin, it belongs within this range right here. So you replace this value right here with medium. And you're going to do the same for all rows. So doing that, you will end up with this. And now, if you do that conversion, you now have a qualitative description of the house area. House 1 is medium, house 2 is large, house 3 is small. So you lose a lot of detail, but you end up with a more generalized categorization of house areas. So how does this help you? For example, if you want to count the frequencies of all of the house areas in qualitative form, you will end up with something like this. So the number of houses that have a small house area would be 3. The number of houses that have a medium area would be 3. And then the number of houses with a large area would be 1. So by converting your quantitative data into qualitative data, you end up with a useful insight. It will basically tell you, do houses tend to be small? Do houses tend to be medium? Or do houses tend to be large? So for this specific example, houses tend to be small and medium compared to large. So you gain useful insight from that. So when you're deciding the appropriate ranges for the bins, you also need to make sure that all possible values are accounted for. So this means here that there must be an existing bin for every possible value. So the bins that you create should be inclusive. So you shouldn't end up with a value where you cannot place it in a specific bin. So this one right here is a good bin assignment, since all possible values can fall into exactly one of these bins. You also need to choose as well the size of the range, how wide the range is, or how narrow the range is. So if you want a lot of bins, if you increase the number of bins, right now you have 3. If you want 5 different bins, for example, you might end up with 2 narrow values. If you want a small number of bins, you might end up with 2 wide of ranges. And the decision in choosing the size of bins is going to be dependent on context as well. You need to study what your values appear in. You need to study what would be the best way to divide your values into bins. So it really depends on context as well. It depends on problem to problem. And that's basically it for this lecture. So as you notice right now, we haven't really talked about applying these concepts into actual tools. So that will be reserved in the next lectures. So right now, we're just gonna study concepts, and maybe in the next video, we will apply all of these concepts right here into an existing data set and using a specific tool to actually perform these conversions, for example. So stay tuned for that. Thank you, everyone.